What's going on, guys? I'm going to start a series of lectures on linear algebra, and I hope for any of my classmates that you find this useful, okay? Because that's really what it's all about. So let's begin. The next test is going to be on this stuff, eigenvalues and eigenvectors, okay? So let's begin. We have this matrix A, this vector U right here, this vector V right here, right? And the special thing is, look, when you do A times V, you multiply the matrix A together with a vector V, the result is just 2V. So what happens is the transformation right here, x onto AX, is for V at least, is really just a scalar multiplication of this original vector V, okay? It's transformed into 2V. That's an important idea. Why is that idea important? Because look, here's the definition. An eigenvector of an n by n matrix A is a non-zero vector x such that AX equals lambda x for some scalar x. A scalar lambda is called an eigenvalue of A if there is a non-trivial solution x of AX equals lambda x. Such an x is called an eigenvector corresponding to lambda. Okay? You think, wow, that is a mouthful. What the heck? What does all this mean? Well, I'll explain it to you. Look, you have your n by n matrix A, okay? If you also have this vector right here, if you multiply A and x together, and that equals the same thing as the original vector times some particular scalar called lambda, then what we have is x is called an eigenvector, okay? X becomes associated with, if this condition right here is true, then x is called an eigenvector, and this lambda right here is called an eigenvalue, okay? And the eigenvector corresponds to lambda, okay? This x right here corresponds to this lambda. That's all the idea really is. So move on to example 2. You have your A, you have your U vector, your V vector. Are they eigenvectors of A? Okay, you multiply A and U together. You see that the result is a scalar, this minus 4, times the original vector, 6 minus 5. Original vector, minus 4. So yes, what we have here is minus 4 is an eigenvalue, and minus 6, or 6 minus 5 is the corresponding eigenvector, okay? You do AV, you see there's no lambda that satisfies our condition specified in the definition, so there's no eigenvalue here, okay? That's all you needed to know. So now let's move on to example 3. Look, what they tell you is they give you this eigenvalue of 7, okay? They want you to find the eigenvectors. Okay, so you form this equation, AX equals 7x from the definition. But the thing is, if you move this 7x to the other side and you factor out the x, then what you really have is this A minus 7I matrix times x equals 0. Okay, so you find the A minus 7I matrix, you get this, you solve the homogeneous equation, and you see that it has free variables, right. It has free variables, I'm sorry. Number x2 right here is a free variable. So you know that you can choose any eigenvalue to satisfy this right here, okay? As long as x2 does not equal to 0, this condition right here is satisfied, which is the exact same thing as this condition, and that corresponds to an eigenvalue of 7, okay? I'm going to move on in the next video. I don't want my videos to be too long, okay? That's the whole point. I hope this idea is ingrained in your head, by the way. Okay? That's all for now. Watch out for my next video.